Hey everybody, Mr. Kowalczyk here again. So today what we're going to be working on is lesson 3, 45, 45, 90 right triangles. And that's going to be standard 16.3. I can find side lengths of a triangle using the properties of a 45, 45, 90 triangle. All right, now in the opener we have triangle ABC where angle A is equal to angle B. We know that BC is equal to 5 and we're asked to solve for AB in simplest radical form. So let's go ahead and take a look at this particular triangle here. If this is 90, we know that all three angles in a triangle add up to 180. So therefore, we have to split this 90 into the 180. So 180 minus 90, as you remember, is 90. Now we have to divide this by 2 because we have two angles here that'll be the same, and that's going to equal 45 degrees. So we have 45 degrees here and here. We know that CB is 5. And because each of these base angles are the same, this is an isosceles triangle, which tells us that both legs are going to be 5, as well as the base angles being the same. Let me erase this so we get it out of the way here. All right, now what we're asked to do is solve for AB in simplest radical form. That means we don't approximate, we just use our radicals. So we've got a right triangle. We can use our Pythagorean theorem, which says that 5 squared plus 5 squared equals c squared. And we'll call this side c, right? All right, so that's going to be 25 plus 25 equals c squared. 50 equals c squared. And then we take the square root of both. C is equal to the square root of 50, which can be broken down into the square root of 25 and the square root of 2. 2 is prime, square root of 25 is 5. All right, so in that situation, C is going to equal 5 root 2. Okay. Now, for this part, we're asked to solve for BC as 1 instead. So that means all that's going to change here is that this is going to become 1. And that's 1. So let's go ahead and work on that over here. 1 squared plus 1 squared equals c squared using our Pythagorean theorem. So that means that 1 plus 1 is 2. 2 equals c squared. We square root both sides. C is equal to the square root of 2 for that one. And let BC equal A instead. All right, well, let's take a look at what this might look like. If this is A and this is A, then we have A squared plus A squared equals C squared. So that's going to equal, working over to the right, we have 2 A squareds equals C squared. Divide by 2. I'm sorry. Scratch that. 2a squared equals c squared. We take the square root of both sides. Now with this, what I'm going to do is I'm going to split it up into the square root of 2 and the square root of a squared, because I know the square root of a squared is just a. And this is the square root of 2 times a. And that equals c right there. So now what we have, and I'm going to rewrite this so it looks a little bit different. Just reverse the 2, a root 2, like that. What patterns do you notice in your answers? Well, here we started with 5, and we got to 5 root 2. Here we started with 1, and we got to just root 2. Here we started with a, and we got to a root 2. For each of those, what we were doing was we were solving for the hypotenuse of this triangle. So what happens is the hypotenuse is going to equal the leg times the square root of 2. 5 times the square root of 2 equals the hypotenuse. 1 times the square root of 2 equals the hypotenuse. Or a times the square root of 2 equals the hypotenuse. So this opener was designed to help us figure out why the rules for 45, 45, 90 triangles work out the way they do. Let's go ahead and label this one here. We're going to have a right angle here of 45 and a 45. And we're going to call this obviously the hypotenuse because it's across from our right angle. Then we have our leg and our leg. And these are going to be congruent to each other because it's an isosceles triangle. All right, now we got that labeled out. Let's come up with our equations. Now, the first one that we just talked about is that the hypotenuse is equal to the leg times the square root of 2. Now, if we reverse that and we want to just solve for the leg, we would divide both sides by 2. And that would tell us that the leg is equal to the hypotenuse divided by the square root of 2. And of course, just like we talked about before, the leg also equals the other leg. They're both congruent to each other. Okay. All right, now let's take a look at this example right here. We've got a 45, 45, 90 right triangle. X is our hypotenuse and 2 root 2 is our leg. So what we're solving for are all 3 legs of the triangle here. So we have 2 root 2 because that's going to be the same there. And then the example, X here is our hypotenuse. Well, we know that the hypotenuse is equal to leg times root 2. So let's go ahead and write that down so we remember it. And then we plug in what we know and solve for what we don't. We know the leg is 2 root 2 times this root 2 here. All right, now, just like we talked about in the previous videos, you can multiply the insides together and the outsides together. Well, here we just have insides. So that tells me that the hypotenuse, which is equal to X, is going to equal 2 times the root of 4, because 2 times 2 is 4. Well, root 4 is 2. So X equals 2 times 2. X equals 4. Okay, that's how we combine those. All right, now let's solve a couple more together here. Let's go ahead and jump into number 1. So number 1, I see here, I've got my leg, X, and Y. Now again, Y is going to be my hypotenuse. My legs are congruent to each other. That means simply that X equals 8. Great, that one's done. Now I know that Y is my hypotenuse, and my rule is hypotenuse equals leg root 2. Therefore, Y for my hypotenuse equals 8 root 2. Now I look at this and I say I've got 8 on the outside and root 2 on the inside. I can't simplify root 2, and I can't multiply them together, so I'm done. All right, number 2. Number 2 says X is here on the leg, and I have 45, 45, 90. Okay, my hypotenuse is 6, and then I'm solving for my leg. So in this case, what I'm going to do is I'm going to go up here to this equation where it says leg equals hypotenuse divided by root 2. Solve for that one. All right, so leg equals hypotenuse divided by root 2. Now I plug in what I know and I solve for what I don't. Leg is X, so I can plug that in. 6 is my hypotenuse divided by root 2. Now, because I have a radical sign in the denominator, I'm going to need to rationalize that by multiplying by top and bottom by root 2. All right, so this is going to give me X equals 6 root 2 on the top divided by root 4 on the bottom. That's going to equal 6 root 2 over 2, because the square root of 4 is equal to 2. Now, X is equal to 6 and 2 are outside, so I can reduce those. 6 over 2 reduces to 3 root 2. And I'm done there. Okay? All right, let's flip over to the next page. Just about done here. We got maybe 2 more to do. Number 3, let's do one more together, and then you can work on the rest of these yourself. Of this set, I got 2 more I want to do after this. All right, so X and Y. Now I'm going to label this my leg, because it's opposite of 45, and then this is going to be my hypotenuse. Okay, so now my X is going to be equal to root 2, because that is my leg. They're congruent to each other. And then my hypotenuse, I'm writing out the formula, is equal to leg times root 2. Plug in what I know. Y for my hypotenuse is equal to root 2 times root 2. Y is equal to root 4. Y is equal to 2. Done. All right, now let's check out number 5 here. The baseball diamond at Coors Field is a square. The distance from base to base is 90 feet. How far does the catcher throw the ball from home to second base? Leave your answer in simplest radical form, and then also round to the nearest foot. So we got to do both. All I'm going to do right now is I'm going to draw the diagram in case you're not sure what a baseball diamond looks like. So a diamond looks like this, and it is a square. It says the distance from base to base is 90 feet. So each of these is going to be 90. Now home base is down here, and then it goes first, second, and third base. And when the players run, if they get a hit, they go this way to first, and then to second, and then to third. And if they make it home, they score a run, just in case you're not familiar with baseball. Now, if there's an opportunity where the catcher who plays at home plate might need to throw the ball to second base in case someone's trying to steal from first to second, they would throw the ball straight there. So now in this situation, we have a 90-degree angle here, 90-degree angle here, and then these 90s are split into 45 and 45. So today our rules apply in that situation. Okay, now you're asked to solve for this distance here, which is the hypotenuse. I'll call that y. You go ahead and solve that. All right, now the last one I'm going to do is number 10 on the next page. And I want to show you one of these kinds of problems that has 2 steps to it, multi-steps. So what we've got is we have a 45, 45, 90 here and another one right here. And what we're being asked to solve for is x, which is the hypotenuse of this second triangle. But we have to work our way from this 9 over to there. So I'm going to put another variable here, y, on the hypotenuse of this first triangle to solve for that. So I know that my rule says hypotenuse equals leg times root 2. So therefore, the hypotenuse of this is going to be equal to 9, which is my leg for this first triangle, times root 2. And that's done there. So this is y equaling 9 root 2. Now I can't do anything with this because that's the hypotenuse of the first triangle. It's also the leg of this bigger triangle here, this second triangle. So now I have to think about my second triangle and how this leg is going to help me find the hypotenuse of that using the same rule. So now my same rule is hypotenuse equals leg root 2, and this is of my second triangle. Yeah, so I'll number these in case it's helpful. And this is my second triangle. So now we know that the hypotenuse, which in this case is going to be x, is equal to the leg, which is this side here of 9 root 2 times root 2. Now I can multiply my root 2's together to get x is equal to 9 root 4. Root 4, of course, is equal to 9 times 2. So x finally is worth 18. Okay. Now in class, you go ahead and do 11 and 12 together. Hope that was helpful. We will see you when we see you.